In the vast, silent expanse of the cosmos, we assumed we were alone in our solar backyard. We mapped the planets, tracked the asteroids, and predicted the comets.
Order.
And predictability. But in 2017, something broke the rules. An intruder pierced our system, moving too fast to belong here.
It didn't circle the sun. It didn't settle into an orbit. It dove in from deep space. And it was leaving.
We named it Oumuamua, the Hawaiian word for scout, because it looked like nothing nature should create. It wasn't round. It was elongated, tumbling uncontrollably, and strange brightness pulses.
Then, the impossible happened. As it moved away from the sun, it didn't slow down. It accelerated.
No gas tail, no visible propulsion. Physics said it was a rock. Its movement whispered machine.
We barely had time to process the first visitor before the universe sent a second.
2019, Comet Borisov. Unlike its predecessor, this one ghosted in with a familiar face, a tail of ice and dust.
It behaved exactly as physics predicted. Ice warmed by the sun, turning to gas. Borisov was a snowball. Oumuamua was a tombstone. We thought we had seen it all.
And then
There was three. In 2025, the silence broke again. 3I Atlas, discovered by the Asteroid Alert System. And this time, it wasn't just a rock.
20 kilometers across.
10 times the size of Oumuamua, moving faster than anything we've ever tracked. It didn't come from the front. It didn't come from behind. It hit us from the side, a T-bone collision with our solar system. To understand Atlas, you must understand our home. The Milky Way isn't just a flat disk. It came from the thick disk, a graveyard of ancient stars, far above the galactic plane. That means Atlas isn't just a visitor, it's a ghost. It's likely a shard of a dead world, a nitrogen ice planet, shattered in a cosmic war billions of years ago. Nitrogen ice. When it melts, it turns into invisible gas, invisible thrusters pushing it faster and faster. And the shape? Not a cigar, a pancake, worn flat by billions of years of cosmic dust.
And just like that, it was gone. Back into the dark.
But the universe wasn't done with us. July 2025, the Atlas system lights up again. This isn't a pebble, it's an island. 3I Atlas. It's hitting us from the blind spot, the galactic north, plunging straight down into the planetary plane. And its path? It's suspicious. It's not just passing through, it's visiting. First stop, Mars. A close flyby. Scanning the red dust, searching for ruins.
Next, Venus, skimming the cloud tops. A gravitational slingshot? Or a data collection run. But Earth? It avoids us. It hides behind the sun. We are blind to its closest approach.
The perfect hiding spot. While it skims our star, our telescopes are blinded by the glare.
A grand tour of the planets, hiding from Earth. Is this nature? Its trajectory points back to the galactic thick disk, the nursing home of the galaxy. Stars twice as old as the sun, 7 billion years. It was drifting before Earth was born. It has seen stars die and galaxies merge. A shard of a planet destroyed when its star went supernova. A tombstone drifting forever. On its way out, it will kiss Jupiter. A final gravity kick to fling it back into the void. But this time, we have an ace. The Juno probe is at Jupiter. It might, just might, get a look.
We have months, not years. The window is closing. If we miss this, it's gone forever.
It will leave us, just like the others, carrying its secrets back to the thick disk. 3 visitors in 7 years. Is the traffic increasing? Or have we just opened our eyes?
Some scientists proposed a bold theory. What if the acceleration wasn't gas? What if it was pushed by light itself?
A light sail, harnessing the pressure of the sun's radiation to navigate the stars. A derelict buoy from a galactic civilization. But there was a problem. It was tumbling. A functional sail faces the star. Oumuamua was spinning out of control.
So we look back at nature. What if it was made of something we've never seen before? Solid nitrogen. We know this material. It covers the surface of Pluto. Vast fields of frozen nitrogen glaciers. Imagine a solar system like ours. A Pluto-like world gets struck.
One of those shards drifted for 500 million years. Cosmic dust sanded it down.
The math works. The nitrogen explains the invisible jets. The erosion explains the shape. No aliens required. Good. Or so we tell ourselves. Because a dead rock is comforting. But Atlas, we can't just guess anymore. We need to go there. Enter Project Lyra, the mission to catch a ghost.
To catch an interstellar traveler, we have to dive into the sun. The Oberth maneuver. A gravity slingshot to reach impossible speeds.
It would take 20 years to catch up. 20 years of silence. Just for a few hours of data. But those few hours would answer the question. Rock. Or machine. Perhaps the galaxy is a graveyard, filled with the wreckage of civilizations that rose and fell long before us. Or perhaps they are seeds, panspermia, carrying the building blocks of life from one dying world. Atlas is leaving us, but it's heading for the stars of Lyra. We were blind. Now we are watching. The Vera Rubin Observatory is coming online. Simulations suggest there are thousands of them inside our solar system right now. We just need the eyes to see them. They are the driftwood of the cosmic ocean. Messages in bottles, waiting for us to read them.
The solar system isn't a fortress anymore. It's a train station. And the next train is already arriving.
To understand the traveler, we must look at the destination. Oumuamua came from the direction of Vega. Vega is special. 14,000 years ago, it was our North Star. Our ancestors navigated.
But Oumuamua didn't start at Vega. It just came from that direction. It was sitting still, waiting for us to hit it. It was at the local standard of rest, effectively a cosmic buoy, parked in the galactic current. We were the ones speeding.
The odds of hitting a rock parked exactly at that velocity? Astronomically low. Unless it parked there on purpose. If not nitrogen, maybe something even stranger. Hydrogen ice. Solid frozen hydrogen.
Born in the coldest hearts of molecular clouds, places where starlight never reaches, where hydrogen freezes solid.
A hydrogen iceberg would be invisible. It would have no tail, no dust. It would simply vanish as it melted. But there's a flaw. Hydrogen evaporates too easily. It would never survive the millions of years to reach us.
So we are back to square one. Too distinct to be a comet, too volatile to be an asteroid, too stable to be hydrogen.
If we want answers, we need speed. Chemical rockets are too slow. We need something radical.
Nuclear thermal propulsion. Heating hydrogen with a reactor core. Twice the efficiency of standard rockets.
Or laser sails, ground-based lasers pushing a probe to 20% the speed of light, catching up in years, not decades.
But every second we wait, Oumuamua gets farther. The energy needed to catch it grows exponentially. 2017 changed everything. It wasn't just a rock. It was a wake-up call. The universe is teeming with debris. The Galileo Project, a dedicated search for the next one. Not waiting for luck, but hunting for evidence. AI algorithms now sift through the noise, looking for non-gravitational acceleration, looking for the weird.
If we intercept one and find a circuit board or an engine, history changes instantly.
Are these the remains of civilization that didn't make it?
We missed the first two. We watched the third. But for the fourth, we will be ready to catch it.
Target acquired.
Consider the timing. It didn't accelerate until after it passed Earth. Did it see something? Did it wake up?
We listened. We pointed our most powerful ears at it. We waited for a beep, a ping, a hello.
Nothing. Breakthrough Listen heard only the silence of the void. If it was a probe, it was in stealth mode.
Or perhaps it doesn't need to speak. A passive sensor, recording our history, our biology, our...
Maybe it's not a scout. Maybe it's trash. A spent booster stage from a launch 1 billion years ago.
We throw our own bottles into the ocean. Voyager, Pioneer, someday.
Let's look closer at Atlas. The red hue? Tholins. Complex organic compounds created when sunlight hits methane and nitrogen. Tholins are the precursors to life. The same red dust that coats Pluto. And panspermia, the theory that life doesn't start on planets, it hitchhikes, riding on rocks like Atlas from star to star. If this theory is right, we aren't just looking at an alien rock. We might be looking at our ancestors. But back to the physics. Oumuamua was spinning fast, too fast. A pile of rubble would have flown apart.
It had the tensile strength of a solid slab of metal, or a single, flawless crystal.
Atlas is so massive it might have its own moons. A traveling solar system in miniature, crossing the void.
These are the dark comets, invisible until they are right on top of us. We only see the ones that glow. Atlas will miss us, but what if it didn't? An object that size, moving that fast.
It wouldn't just be a city killer. It would be a planet reset. The kinetic energy of a mountain moving at interstellar speeds. Fortunately, we have a guardian, Jupiter. Its gravity acts as a shield, tossing these intruders out before they get too close.
But the question remains, why now? Why 3 in a decade, after centuries of silence?
Is it just better technology? Or are we drifting through a dense cloud of galactic debris? A patch of rough road in the Milky Way? Whatever the reason, the era of isolation is over. We have entered the interstellar era.
We can't chase them fast enough, so we stop chasing. We start waiting. We set an ambush.
The European Space Agency's Comet Interceptor. A hunter lying in wait at Lagrange Point 2.
It sits there, fuel tanks full, batteries charged, waiting for the call. Maybe for years.
Target acquired.
When the next Atlas or Oumuamua appears, we don't need to launch. We are already there. We just burn hard to intercept.
And it's not one ship, it's 3. Before impact, it splits. A mothership and 2 scouts.
3 angles, a complete 3D model. No more guessing about pancakes or cigars. We will see the truth in 360 degrees.
And one day, maybe we don't just look. Maybe we grab a piece, a sample returned from another star.
But to catch the fast ones, the Oumuas, chemical rockets aren't enough. We are limited by the tyranny of the rocket equation.
Ion drives, electric propulsion, low thrust, but they never stop pushing. The tortoise that catches the hare. Or Starshot, swarms of chip-sized spacecraft. If you can't send one big ship, send 1,000 tiny ones.
The Watchers aren't human anymore. Artificial intelligence now guards the sky, scanning for the next visitor 24/7.
It will happen again. Maybe tomorrow. Maybe in a decade. A notification will pop up on a screen in Chile.
And this time, we won't just watch. We will light the candle. We will go to meet it.
The journey will be long and lonely. Out past Mars, past the belt, into the deep cold. We arrive.
And the camera opens, and we see geometry, symmetries, lights.
We look for biology. Wet, squishy life. But maybe the universe is full of post-biological...
Von Neumann probes, self-replicating machines. If you launch one, in a few million years, they are everywhere. Is that what Oumuamua was?
Or are we in a zoo, a nature preserve? The probes just pass by to count the animals, making sure we stay in our cage.
Or a quarantine. Maybe we are the dangerous ones, and they are just checking if we've learned how to leave yet.
Rock, ice, or machine, it doesn't matter. They held up a mirror to us. They showed us how little we know.
The scary part isn't that we saw 3. The scary part is that for every one we see, there are 10,000 we miss. We used to think the Oort cloud was a wall, a bubble protecting us. It's not. It's a sieve.
At any given moment, simulations predict there are 10,000 Oumuamua-sized objects inside the orbit of Neptune.
They are here right now, drifting in the dark, passing Mars, crossing Jupiter.
The Scout, the Ghost, the Titan. 3 distinct classes of traveler.
But the era of blindness ends now. The Vera Rubin Observatory, the greatest movie camera ever built. It will scan the entire southern sky every 3 nights, creating a motion picture of the universe. If it moves, we will see it. We expect to find not 1 per decade, but 1 per month. We are about to be flooded with interstellar visitors.
How will it change us? Knowing that our system isn't a lonely island, but a busy intersection in a galactic city?
There is a theory called the Dark Forest, that the universe is silent.
We are the only ones making noise, lighting a campfire in a dark woods. Are these visitors looking at the fire?
But fear is the enemy of discovery. We choose to look. We choose to chase. We choose to know. Atlas will be gone by 2026, a fleeting shadow. But it woke us up.
The sky is getting busy. Apophis in 2029. The return of Halley in 2061.
We are entering the Golden Age. Never in history have we had so many eyes open at once.
The universe is knocking on our door, throwing rocks at our window, trying to get our attention.
Are we brave enough to answer? To catch the next one? To open the bottle and read the message? We spent thousands of years looking at the planets. The next 1,000 years, we look at the stars. This is our home. But the visitors remind us, it's just one house in a very large, very crowded neighborhood. And the next visitor is already here.
So we keep watching. We keep listening. Every byte of data is a piece of the puzzle, a pixel in the grand image of our galaxy. Somewhere out there, Voyager is the intruder, spinning through the dark, a strange visitor to another world. Stardust to stardust, debris to debris. The cycle continues, with or without us. The rock, the comet, the mountain, 3 messengers, 1 message. Look up.
The next discoverer isn't a machine. It's a child looking up tonight, wondering what's out there.
We are ready. We are listening. And the door is open.